Hello guys, in this video we're going to try to solve a couple of trigonometric equations. So in this case here we have sine x times tan x equals to sine x. So now one thing to know here is that you should never, in this case here, divide by sine of x, because dividing by sine of x, as you can see, if I do that, then I would actually get rid of sine of x, okay? So it will be gone. There's no way I would get such solutions, the solutions that would come from sine of x. I would not get them. I would just end up with tan x equals to 1, which would give me some other solutions, but not the solutions for this problem here. So some things would be missing. Therefore, we have to consider the different routes to the solutions. So one thing you can do, you can actually subtract sine x from both sides. Okay, so meaning that you move it over, which I'm just gonna do here. I don't have to do these extra steps, so I'll just do this, sine x, tan x, minus sine of x equals to 0, because I subtract sine of x from both sides. Then from here, you have two terms here, so GCF here is sine of x. We can factor sine of x out. So we have sine of x factored out as the GCF, then tan x minus 1 here equals 0. Okay, and all we got to do now, we have two factors equal 0. So one of them has to be 0. So it's either sine of x is 0 or tangent x minus 1 is 0. Okay, so we have two equations to solve here. We can solve the first one, angles, but by the way, we're solving this within, so this interval here, knowing that x is between 0 and 2 pi here. Now between 0 and 2 pi here, and the value of x can take 0, but it cannot take 2 pi. Okay, so we keep that in mind. Then now what we have here, we need to get solutions for x, values of x between 0 and 2 pi. So x is an angle, so the angle whose sine is 0, and this interval, we can find actually two angles. When x equals 0, sine of 0 is 0, and also when x equals to pi, sine of x would be 0. Okay, so sine of 0 is 0, sine of pi is 0. Okay, these two angles, remember x is an angle. All right, now we have these two solutions. Let's get the other solutions here. Now if you move the 1 over, you have tangent x equals 1. Then so now you need the angle or angles in this interval here, within this interval, whose tangent would be 1. Now an angle like this, we know in the first quadrant, now positive 1, that angle in the first should be in the first quadrant or in the third quadrant. And by that I mean, I'm talking about the first quadrant here and the third one. So this is where tangent is positive. Okay, where tangent is positive, first quadrant and third quadrant. So now we know the angle here would be pi over 4. Okay, pi over 4, that's where tangent is 1. So I'll put x3 equals to pi over 4. And also here, because this is 0 right here, and pi, and if we go full circle, it's 2 pi, you know. Then this is pi over 2 and 3 pi over 2. Now, so if I go from here, from 0 all the way to 2 pi, I can get these two angles, pi over 4. Then the other angle here, that would whose tangent would be 1, is again 5 pi over 4 right here. So it would be exactly here. So pi over 4 and 5 pi over 4. So x4 equals to 5 pi over 4, okay? So pi over 4 and 5 pi over 4. Now, again, how did I get to this here to know which angle is here? You know, pi over 4 is 45. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which would be pi, then 5 pi over 4 right here, okay? So it's easy, you can easily get it, okay? So therefore, the solution to this equation will be, solution is 0 pi over 4 and 5 pi over 4. Okay, so this is what we have as the solution. So 0 pi over 4, 5 pi over 4. This is what we have as the solution to this equation right here. Okay, so this was number 1. I'm going to try to solve another one with you guys. Okay, so this is for orders. This was straightforward. You just use your basic skills from algebra, from your algebra class, to factor out the GCF here. Then you easily solve for x, okay, which is the angle. All right, so now let's try another one here. And remember not to divide by something that will eliminate one of your factors, because that would eliminate some of your solutions. So be careful. All right, let me try another one. Okay, let's try another one. Let's say we have another one. Let's say we need to solve this one. We have 2 sine squared x minus 3 cosine x equals 0. So let's say we have this one. Again, we have an interval to get x from. So x is between 0 and 2 pi, inclusive on the left here, okay? But 2 pi is not part of the solution. Okay, so now, in this case, what you do, you remember last time I told you, for the one we just solved, we use some basic property of in algebra. So now you could just factor out the GCF. But in this case here, there's no GCF, okay? There's no GCF in this case. So the best thing to do is to try to make the terms look alike. So for example, I can try to have only cosines or only sines. But in this case, let's go only cosine, because I know one identity. One identity I know, because I have sine squared here, is cosine squared x plus sine squared x. So I can use identity equals to 1. This is one thing we know, okay? One identity we know. Then if we know this, we can actually derive sine from it. So I can, because I need to get sine in terms of cosine. So I can solve for sine squared of x. Sine squared, therefore sine squared of x would be 1 minus cosine squared of x, right? Okay? 1 minus cosine squared of x. From here, we can replace sine squared by its value. So I have 2 times, now sine squared, replacing it by 1 minus cosine squared x, okay, minus 3 cosine x equals 0. Okay, so far so good. Now I can distribute here. I have 2 minus 2 cosine squared x minus 3 cosine x equals 0. Again, we're still good here. So now I can try to move everything to one side. I'm going to move everything, let's say, since this is negative 2 cosine x squared, cosine squared x, I'll say I'll move the 0 to the other side, or I can just multiply everything by negative 1. Doing that, I would get positive 2 cosine squared x. It becomes positive now because I multiply by a negative 1. Let me show it to you. Let me say this. Multiply by a negative 1, okay? Then I have positive 2 cosine squared x and positive 3 cosine x minus 2, right? Minus 2 equals to 0, okay? Now I rearrange it so it could look like a quadratic equation, right? Now, you could easily factor here. This is like a trinomial. So again, if you don't remember how to factor trinomial, refer to one of my videos in which I showed you how to do it, okay? Now we can factor here 2 cosine x, cosine x. Then I need 2 factors of 2. So 1 and 2. I put 2 here because when I multiply here, 2 cosine x times 2 would give me 4 cosine x. And I need it to be positive 4 cosine x minus 1 cosine x to give me 3 cosine x, okay? And negative 1 times 2 would give me negative 2. So I'm good here. This is how you factor this. Okay, now 2 factors would give you 0. So 1 has to be 0. Cosine x, product of 2 factors, I'm saying. 2 cosine x minus 1 equals 0. Or cosine x plus 2 equals 0. Okay, so we have 2 equations here. Now, first one here, if we divide both sides by 2 here, we move the 1 over and we divide both sides by 2. It becomes cosine x equals to 1 over 2. We can get this angle here because cosine x can be 1 over 2. But if we do this, it will be cosine x equals to negative 2. In this case here, no solution. No solution here because there's no angles for which cosine x would be negative 2. This is not part of the domain, okay? For x. X cannot be, any value you give to x will not be negative 2. Okay, that has to be between negative 1 and 0. Okay, so in this case, no solution. Now, cosine x is 1/2 here. Now, for this, the angle whose cosine is half, again, positive half, I'm saying, okay, you can draw. It's good to do this most of the time, okay. So first, second, third, fourth quadrant, where is cosine positive? Cosine is only positive here and here. This is where you have positive cosine. And this second and third quadrant, cosine is negative. It's only positive here and here, the first and fourth quadrant. So this is where you're gonna have to grab your angle for this one here. So the angle in the first quadrant whose cosine is half, the angle in the first quadrant whose cosine is half is pi over 3, right? So x1 is pi over 3. Again, there's a way to memorize these. I showed it to you in another video of mine as well. So you can actually check that out in my trigonometry playlist, okay? Now, the other one here, the other angle here in the fourth quadrant, whose cosine will be half, but it ends up, and it's in the fourth quadrant, is 5 pi over 3. Okay? So this is how you know that the solution is then, the solution is pi over 3 and 5 pi over 3. Okay? So this is how, so sometimes when solving trigonometric equations, you will have to just use some basic knowledge of algebra, basic skills you get from your algebra class. It could be college algebra. Now, you could either factor, whatever the skills you have from that class. or you will have to use some identities. So make sure you learn the identities, and those will help you a lot in your trigonometry class. Shouldn't be too bad. It's just that you need to place your mind and make sure you understand what's going on. Okay, thank you.